Mathematics, anyone? Welcome to our class. Today is Algebra 2. Our topic for today is definition and using sequences and series. I wrote one problem right here. It says find the first 5 terms of the sequence in this problem. Here I have to tell you something. For instance, n represent the position, okay? That is the position. And then we have another variable there. Only the position, but also or the term in the space, or the term in the space. In the space. In the sequence, right? Sequence. Okay, the sequence. All right. Yeah, the n represent the position of the term. Yeah, or not, or of the term in the sequence. Okay, in the sequence here. So start our problem start. We have to start with n equals 1. Okay, n equals 1. So I will to work in this problem. Okay, with this information, with this data. All right. Okay, first step here in our problem, we have to find the first term. So find the first. I will write right here. Find the first term. The first term. So here we have to plug it in. N equals remember, plug it in n equals 1. All right, n equals 1. In this case, we will have here. I will solve the problem. My problem right here. So we have this negative 7n minus 9. So let's write right here negative 7n minus 9 equals, now plug it in the n equals 1, so it's going to be negative 7 times 1 minus 9, right? So negative 7 times 1 is 7 minus 9 let's write again as negative 7 and negative 9. So simplify right here. It's very easy. So it's negative 6. Okay, that's our first step. the second term, just continue like this. So here is going to be the second term. Let's write negative 7 again. Negative 7 n minus 9 equals a negative 7. The second one, just give it a number. We have to find the first 5 terms. So n equals 2, n equals 3, n equals 4, and n equals 5. Right? Those numbers. So let's write the second one is 2 minus 9 equals negative 14 minus 9 equals how much is it? It is 14, it is 23. Negative 23, right? So the third one, let's write negative 7 and minus 9 equals negative 7 times 3 minus 9 equals 7 times 3 is negative 21 minus 9. Just simplify here. It equals negative 30. Negative 30, right? Negative 30. Next one, let's write negative 7 and minus 9 equals negative 7 times 4 minus 9 equals 28. Negative 28, right? Negative 28 minus 9 equals negative 37, right? Negative 37. See, now the last one is a negative 7n minus 9 equals negative 7 times 5 minus 9 is equals negative 35 minus 9 equals negative 44, right? Negative 44. Negative 44. So it's done. So the first 5 terms of the, let's write it first as a conclusion. The first 5 terms of the sequence n minus equals negative 7 and minus 9, okay, are, so here I will write it here, are we got it, negative 16, negative 23, negative 30, negative 37, negative 44. That's the solution to our this problem. So okay, this is the first part of my class. Actually, I will divide my class today in 3 different parts, 3 different sections. First section is like this one. Let me go to this part number 2, section number 2. I will show you some rules of the sequence. Okay, this is the beginning of my class, or the second part or my class. I will tell you about write rules of for the sequence. So write rule for sequence. Okay, we have to write some rules for the sequence in this case. So let's write. Let me write one problem. Like let me write easy ones. 0. Let's write 0, 1, 3, 4. I write 3 is enough, and then so on. Okay. So we have to find a with the base n equals. So the answer right here. We don't know the answer right here. Okay, so we have to write here. We have to write an expression to describe. We have to write an expression. It says write the rules for the sequence. In this case, we have to write an expression to describe this sequence. We need to write some expression to describe this sequence. 0, 1, comma. No, let's write continue. 2. Let's write 2 and comma 3 because 3 and so on, like this, exactly like that. Okay, so we have to use the n to represent the position of the term of the sequence. All right, like the first problem I give it to you for the first term. So the sequence, let's continue. Like maybe 1, 2, 3, you immediately see 4. But we have to write an expression to describe this sequence. Okay. Let's see the sequence. Let me write the sequence. Could be like is here is n minus 1. Let's see, n minus 1, right? And then we have to check the first 4 terms. We have to check the first 4 terms to see this. So it started with n, also again n equals 1. We have to start it with that, and then let's see it. Let's see how work this problem. Okay. Fine. So the first one here, let me write some to the beginning. The first, the first four terms. The first 4 terms, yeah, like that. So we have to plug it in. N equals is n equals 1. Let me substitute. Let's write right here. Start it right here. N minus 1. Here, let's write n is equals 1 minus 1. The first term is equals 0. See? Look at this. We have to. It's very easy. It looks like easy, but it's confused. So the second one, just write again n minus 1 equals equals 2, n equals 3, n equals 4. Let's write with 4. So we have to describe this sequence. Write an expression. Here, let's write 2 minus 1, so it's equals 1, right? 2 minus 1 is equals 1. The next one, the third one. Actually, let me write something here. It's a cool. First, second, and then third. Third. Let's write n minus 1. This is number 3. So let's write 3 right here. Minus 1 equals 2. See the sequence is coming, right? It's coming. See. So the next one, 4. The fourth term. Let me write n minus 1 equals 4 minus 1 equals 3. So, see the sequence? The first four numbers right here. I write that. Okay. So this sequence. The answer. This sequence I will write right here. This sequence. This sequence is, the numbers. This sequence like 1, 2. Started with 0, 0, 0, 0. Yeah, this sequence like 0, 1, 2, 3, and 4. Yeah, and 4, right? Describe it by what? By the expression n minus 1. N minus 1. See? That's the solution. That's the answer. Now, let me show you one more different definition and how using the sequence and series. All right, I will erase this problem. Oh, I didn't answer right here, but the answer I write it right here. It's n minus 1. Okay, that was the answer. The expression that describes our problem. So let me go to the part number 3 of my class. In this section, let me talk about I will to you introduce the sigma notation, okay, of sigma notation. All right, so we have this classify the series. The sigma notation is classified classify the series. We used to write this sign, this symbol. Okay, remember the symbol? Sometimes I confuse the students in algebra when using this symbol. Remember the symbol? This is a sign. Here, for instance, you write it here 96. Let's write 96, and then here in the below n equals 1. And then here just write a -2. That's the classify that side. So first of all, we have to remember this. A sequence is a like concept is an ordered of how say numbers. Yeah, numbers. Yeah, a group or piece of numbers, whatever. The series, a series. So this is another main thing that we have to understand. Is a sum. This is a sum or addition over the sequence. So the sequence how say the difference? A sequence is like not like let's write series and here sequence. See, a sequence is an ordered series of the numbers. A series is a sum of the sequence of the numbers. All right. So this is the first idea or the main concept about this. Okay. Then a sigma notation, in this case, a sigma notation it is the infinity here, the sigma, like it's a concept, the sigma to understand this. It is the infinity series. It's very important when you see the infinity series of for instance, let's write A1 plus A2 plus so on plus AN right there is written like a symbol, this symbol like this. Let me do again. So like this. So here is M, and the bottom just write N equals 1. N equals 1. And here just write AN. Got it? All right. Look at the formula. This is very, very basic. Let me show you. I will explain step by step. Now, to found, and in this case, I mean, where remember the formula I wrote right here. Where let me write is very important. Where explain to you where A and remember the A and I wrote right here. Let me write actually the sign. It's very important. Let's write right here the sign. So let me write M right here. N equals 1 and then AN right here. So you need to understand this first, because this is very basic. Here is the like the n term. Very important. Everything in series. Okay. Here, look this idea. The lower limit, this case, look at this. The lower I need to write it. Is of the series. Is this number right here? Is this number right here? Lower series is the index. It's called the index. Let's write here index, right? Is the index of the first term. Of the first term. Okay, very, very important. And in the first and this sign in this sigma, okay. This let me write on this thing, okay. So this is very important here index. Now let's talk about the upper. This is a lower. Now the upper, I mean this letter, this variable, let's write the meaning. The upper limit the upper limit of the series is the index see, of the last term. Okay, this appear right here. As m right here. The lower limit appear in n equals n in the bottom. Okay, is this one on the top. Okay, so let me solve this problem. This problem after I explain it to you. So this means this is the in our problem. This is the limit of the series 96. See, and then the lower limit of the series is the n equals 1. That's the lower. It's the beginning. It is the beginning. So it's with the series start. So start with this number and then finish with 96. Okay. Let's solve this problem. Okay. We have that problem right there. Look the series right there. Look at the series. So here, n, the lower index is equals n equals 1. The upper index is 96. That means this is the finite series. It is 96. The series is finite. So this means the one thing right here mean it is 96. This is right as conclusion is the finite. Is a finite. Yeah, it's a finite number of the terms. Number of the terms, of course, in the series. So I don't want to continue writing in the series. So there is one term. There is one term for over value of the index. So how started? So starting at we have to starting at n equals 1. N equals 1, right? And the ending, at n equals 96, right? So it's very simple. So to work, right? So let's it's done. So I just explain it. So solution here. As a conclusion, how simplify so yeah, there are in this problem there are 96 integers or term from 1 to 96, right? 96 term or integer, but it's an integer is its own single number, right? So there are 90. Our conclusion. So there are 96. There are 96 terms in the series. It's just explaining what I mean this. Okay. So now let's solve one problem in this section. This section. Let me solve one problem. let's write one, classify the series. Find the series. Classify the series. Let's we're a little different. Let's write the sigma right here. This is the sigma, the sign sigma, called sigma. Okay. Let's write 20 right here, and then and it's affinity. It's affinity, and then here 3n minus 1. See? Oh, this one. How so it's affinity or infinity. So solve a problem. How solve a problem here? In this case, at the beginning, it is 20 immediately, right? So it is 20 right here. So this is finity series, because we have to write to see first thing, infinity or finity. First, it's the first thing that we have to decide. So this guy, it is 20. We have a number right here, so it is finity. This is finity. See? It's affinity in the numbers of the terms in this area. So it is affinity numbers on the terms on the series. It is 20. Okay. What is there is one term also. There is one term for the index. So the index, the low index is n equals 1. So how write as a conclusion here? We have so this is starting right, starting at n equals 1. Okay, n equals 1. Just very don't be confused. So starting, it's start in that at that point, and the ending series is at n equals 20. I solved one problem at the beginning, so you have to work in this way. I don't want to make all operation. So here in this problem you work using this like little equation, right? There are here there are 20, so 20 integers from 1 to 20. 1 to 20. So here, as a conclusion, there are 20 terms in the series. Okay, you wanna know, just do it. Remember, this is your formula, and then start with this number. When not negative 1, so it's n equals 1, right? Sorry, right there. N equals 1. It's not negative. This means equals. So start with this equals 1. Start with this number and finish in that number. 20. It is 20. Then the terms. There is 20 of the terms or it is finite, the terms are in the series, okay? So you wanna do, just do it, and then remember the problem that I solved at the beginning. That's why I told you I also divide my class in 3 different parts. The first part, I show how work with these problems, with this thing, right? The second part, we try to write the rules for the sequence. When you have a sequence, we solve one example. And here, this is another problem. Just it's introduction. It's not complex problem. Today, my class is like introduction to this of the sigma notation. What I mean these signs. A lot of times, you will see these signs, and then students sometimes they don't know what I mean this. In the series or the sequences, we need to understand this sign. See, this index, the low one, this is the low index, mean the series started right here, and then the upper number right here, this means finished. In this case, you have a number, a specific number, the series finitive, sometimes infinity, the series, the notation, but in this case, and this problem, since we have 20 right there, it's finite, right? So that's it for today. Some definition. It's not deep class, so that's in general some definition, and then using sequence and series in Algebra 2. So thank you so much. I am here, remember, Mondays, Wednesdays, and Fridays, also at this time between 5 and 6 p.m. At this time when you are at home doing some homework or something. So this is great for you, for Algebra 2. It's very helpful in your homework, also in classroom too. Okay? So thank you so much.